Why is the vacuum pump gauge reading worse than rated? Does altitude affect the vacuum performance? Have you noticed your vacuum pump shows a worse reading than its claimed rated level? That's because it has relative gauge instead of an absolute gauge on it. This could result in difference in vacuum readings. Why is there a difference in readings between relative and absolute gauges? At mean sea level, the average pressure is 1 atmosphere, or 1013 millibar. We can assume that means there are 1013 air molecules. However, atmospheric pressure is variable. At higher altitude, air is less dense, which means less free air molecules. In contrast, there are more free air molecules at lower altitude. For a relative gauge, it always assumes the ambient air pressure is 1013 millibar. And it calculates the vacuum level based on the discharged air. Taking Rocker 300 for instance. Its rated vacuum level is 99 millibar, which means it can discharge air until 99 air molecules are left. At 1 standard atmospheric pressure, there are 1013 air molecules in the vacuum chamber. When the pump works until 99 air molecules were left in the chamber, that means it has taken out 914 air molecules. The relative gauge does the calculation like 1013 minus the discharged 914 air molecules equals to 99 millibar. But if the pump works at an altitude of 900 meters, like a high-rise building or a mountain, where the free air molecules are only 893, when the pump still works until 99 air molecules were left, it has taken out 794 air molecules. Since the relative gauge assumes that there are 1013 air molecules under all circumstance, leading to a mistaken calculation of vacuum level as 219 millibar. However, considering the actual ambient atmospheric pressure is 893 millibar, which is 120 millibar less than 1013, it can be concluded that the gauge readings differential was caused by air density due to altitude differences. Next question is, how to determine the actual vacuum level attained? Firstly, you can find the altitude of your current location, add it with the height of the building, sum them up, and apply it to the formula. Theoretically, the air pressure decreases 1 millibar as altitude increases every 9 meters. So if you're located in a 9-meter high building at an altitude of 2,750 meters, that makes 2,759 meters. 2759 divided by 9, times -1, equals -306. -306 millibar from the gauge reading. And you'll get a closer value to the actual vacuum attained. However, atmospheric pressure can be affected by many other factors, such as temperature, weather, or so on. So the calculated value can still deviate. The best way to know the attained vacuum is to measure with an absolute gauge. In contrast to relative gauges, an absolute gauge always shows correct ambient atmospheric pressure. Just simply connect it to the vacuum pump, and you'll get actual vacuum level. If this video has been helpful to you, please subscribe to our channel, where we share useful information for your lab. Until next time, bye.